All right, we are on SAS 3, page 119. So this graph is talking about the end behavior. So on number 1, it says describe the end behavior. So what you're looking for in the end behavior is what are the ends doing. So first, if we look on the left side where it is concave down, we see that the end behavior is pointing down. If we look on the right side and we see concave up, points up. So this graph, it shows you f of x equals x cubed, which is the gray graph, and f of x equals x cubed plus x squared minus 3x is the red graph. So I am going to hit the 2x, and if you notice, the higher I get, the larger my graph gets. So what that means is if you click to page 2 on Agile Mind, it shows you that cubing a larger and larger positive number will produce a larger and larger result. So what that means is the graph on the right was up to 10x. You see that the graph is larger. You see the graph is more stretched out. So this graph is closer to y equals x cubed. Same thing for the left side. It is smaller, so my graph is smaller. If you look at the values, they're only going up to 10. So this is they're just going up by 1 each time, whereas the right's going up by 10. So over, what you want to write to explain this is larger values equal a larger result, which goes for this graph. And then this is all on number 1, by the way. A smaller value equals a smaller result, which goes for this graph. So you're just looking at how big and how small the graph gets. All right, on page 4 on Agile Mind and number 2, it says, how would the end behavior be different for a cubic function in which the leading coefficient is negative? So remember, a leading coefficient is me saying y equals negative x cubed. So my leading coefficient here would be a -1, okay? So since it's negative, it would first decrease rather than increase. It will point up first, and then it will point down. So if I were to graph y equals negative x cubed, it would look something like this. So you see it's decreasing. You see first that it points up, and then it points down. If you flip the page to page 120, it asks you, how would you describe the end behavior of a quadratic function? Let's see if it shows us the picture. Yes, it does. All right, so here are your two quadratic functions. Okay, you have that on number 3. So the first one, my ends, or both 1 and 2, my ends point in the same direction. However, when it is positive, it points up. And on the bottom, when it's negative, it points down. Another way to write this by saying it points up is saying f of x equals infinity, because we don't know where that graph ends, but we know it's on the top side of the graph, so we know it's a positive infinity. And if it's pointing down, another way to write it would just be, let me erase something, would be to say f of x equals a negative infinity, because we don't know where the graph ends, but we do know that it is negative, so it's just going to keep going and going and going in the negative infinity direction. All right, so now on page 5, we're talking about quadratic functions. We know that a quadratic function points up and looks like a U if it's positive, and if it's negative, it points down and it is an N. So, it says, when you studied quadratic functions, you learned that there is a relationship between the factors of the quadratic expression and the real zeros of a quadratic function. So, we're starting on the right. It says the function on the right, f of x equals x squared minus 4x plus 3, can be factored over the real numbers. So what that means, if it can be factored, then it's going to have something called a zero. Okay? 0, write this. This is not a question, but on number 4 on your paper, write 0 equals x intercept. All right, so it says it has 2 different linear factors. So the function has 2 distinct real zeros. All right, if it says the word real, you know that you can actually see it. So I'm circling my zeros. So I have a 0 or an x-intercept at both 1 and 3. Okay? Now, the middle graph is x squared minus 4x plus 4. It can also be factored, but it has something called a double factor. So you see how it only crosses at 2? All right, so that means it only has 1 real zero, so you can only see one of them, okay? 1 x-intercept. Now, the last one we will talk about later, and it will actually have an imaginary number, but for now, just know that it doesn't cross the x-intercept, or the x-axis, so it has no x-intercepts. No real zeros, so it cannot be factored. All right, if you go to page 6, if you do not know this formula, now would be a great great time to learn it. This will help you tremendously on the ACT. I would bet about half of the ACT has you use this quadratic formula. So when we are in class on Thursday, I'll teach you the song, and I'll also upload it on Teams so you can go ahead and learn it. You'll think it's silly, but I promise you'll never forget it. Okay? So, quadratic formula. Quadratic formula is a way to find the roots, which are called zeros, which are called x-intercepts. So on number 4 where you wrote zeros equals x-intercepts, go ahead and add equals roots. And you only use this formula right here for a quadratic equation. And you have to remember that a quadratic equation has a squared. Okay, so it says you have used a quadratic formula instead of factoring to find zeros of the functions graphed in the middle and on the right. So that's where this comes from. They factored it. But now I am going to use this quadratic formula to answer number 4. So I am going to swap over, not to that, to this. I'm going to go ahead and write the formula so you have that. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So we have this function, x squared minus 4x plus 6. So a values, they always go with x squared. You're just using the number in front of x squared. So a is just going to be 1. B goes with the number in front of the x. So that will be a negative 4. And C is our constant, which means it doesn't have a letter, so that would be 6. Now, in order to do a quadratic formula to solve, your equation must be set equal to 0. So since it is set equal to 0 right here, then we can solve. So now you have A, B, and C. All you're doing is plugging in your values. So go ahead and do that. Make sure when you plug in, you use parentheses, though, because it'll mess you up. All right, so most of the time, you could put this in a calculator, and I'll show you that in just a minute. But for now, let's just solve the old way on your paper, okay? So you have to think right here. These two negatives make a positive. So we have 4 plus and minus the square root. Now we have to simplify what's under the square root. So we're looking at negative 4 squared. Negative 4 times negative 4 is a positive 16. Then we have minus, I just brought the sign over. 4 times 1 is 4, times 6 is 24. On the bottom, 2 times 1 is just 2. So now we want to simplify even more. 4 plus and minus 16 minus 24 is negative 8 over 2. Now, we have to stop right here because we cannot take the square root of a negative number. If you take the square root of a negative number, you will get something called an imaginary number. We will do imaginary numbers in topic 8, maybe. So for now, we're going to stop right here. And this would be our answer. And that's why we don't have any, I'm tracing over the graph, we don't have any distinct real zeros because it is imaginary, therefore you cannot see them. Okay? So I'm going to delete this and I'm going to show you what it would do if we typed it in. All right, so when you type in on the calculator, you cannot put a plus and a minus in there. So you would have to do 2 different equations, okay? So I'm plugging in go ahead and do your fraction bar. Negative 4, because that's my B. I'm going to do plus first. Plus the square root of B squared minus 4AC all over 2A. And it tells us that it is a non-real answer. That's because there's a negative 8 under the square root, and it is not real because it is imaginary. Now, if I wanted to change this, here's a trick, easy way, that way you don't have to type it all in. If you go up and you see where it's highlighted and you just click enter, you can tab all the way over to the plus, simply just change it to a minus and hit enter again, and it's still going to tell you it's a non-real answer, okay? Let's see. Now, let's talk about why for a square root there's a positive and a negative number. If I have the square root of, actually no, if I have negative 4 squared, that's the same thing as me saying negative 4, you don't have to write this down, I'm just showing you, negative 4 times negative 4, which is 16. That's why we have a positive and a negative, because you know that 2 negatives make a positive, okay? All right, let's look at, and if you click check, then it shows you the same thing that we just did. All right, here, number 5 is a little bit easier, I think. So it says, if you can factor a quadratic expression into linear factors, you can find the zeros of the associated quadratic function as well as the x-intercepts of its graph. The same reasoning can be used to analyze polynomials of higher degree. So a higher degree would be 3 or higher. So for this one, we're doing the exact same thing except we have to do factoring. Y equals x cubed minus x. So the way that I teach factoring is by first labeling my x's. So in this first one, I have 3 x's. Okay? In the second one, I only have 1 x. So when you factor, your goal is to get what you started with, but just in a simpler form. Okay? So look at your green x's. How many do they both have? Like they at least have how many? They at least have 1. There's 3 here and 1 here, but they at least have 1. So we're pulling out just 1 x. Now, I want to get an x cubed, but I only have an x. So to get an x cubed, I need to have 2 more x's. In my red equation, my original equation, I have a negative x, but in the green, I have a positive. So in order to make that a negative, I need a negative 1. Okay? Now, if you look over at your graph, on your paper, I want you to circle the negative 1, the 0, and the positive 1. So there, I have 3 real zeros, 3 x-intercepts, 3 roots, whatever you want to call them. So to simplify the green, you can't simplify the x anymore, so you just keep it. But to get an x squared minus 1, make this a little bit smaller. I have to have 2 more factors. So we know we got to have an x and an x. Minus 1 and a plus 1. So what's in green right here are my factors. But I want to find my zeros. So this is the most important thing today. You set, I'm going to write this, set factors to 0 and solve for x. That is how you find your x-intercepts, your roots, or your zeros. So this lonely little x, right here, nothing goes with it, so it's the easiest one. You are literally just saying x equals 0 for that one, and there's your first root, right here. Next, you say x minus 1 equals 0. Well, I want to solve for x, so I'm going to have to add 1 to both sides. So x equals 1. There's my second root. Lastly, I have x plus 1 equals 0. And I have to subtract x equals a negative 1. There's my third root. So I have 1, 2, 3 roots. And 1, 2, 3 roots. Okay, so I've jumped over to page 10 on Agile Mind, and now we are on page 122, number 6. So first, for number 6, I want you to draw me a chart, and it's going to look like this. All right, so I'm going to give you 3 functions, okay? They're all going to be cubic. The first one is f of x equals x cubed plus 2. The next one is f of x equals x cubed minus x squared minus 8x plus 12. And the last one is f of x equals 1/3 x cubed plus x squared minus 3x. All right, so what I'm going to do now is I'm going to graph each function rule. And what you are telling me is the number of zeros that it has. So the number of times that it crosses the y-axis. So the first one is x cubed plus 2. And I'm going to hit graph. And you see that it only crosses one time. So to the right of that function rule on your paper, you need to put that it just has 1 0. Okay? It just crosses one time. All right, now I'm going to graph x cubed minus x squared minus 8x plus 12. When you hit graph, you see that it crosses 1 and 2. So it has 2 zeros. If you graph the last one, which is 1/3 x cubed plus x squared minus 3x, you will see that it graphs 1, 2, and 3. So it crosses 1, 2, and 3. Okay? So what you gather from this is that all 3 were cubic functions, but one of the functions had 1 0, one of them had 2, and one of them had 3. So you can have at most 3 real zeros. You cannot have more, but you can have less. You just cannot have any more than 3. So on number 7, it says, think about linear, quadratic, and cubic polynomials. Based on the 3 function types, what seems to be the relationship between the degree of a polynomial, which is also known as the power, and the number of the distinct real zeros it will have? So, right here, it tells us if it's a linear function, it has a first degree polynomial, it will have exactly 1 real zero. Okay? If it is quadratic, which means it's a second degree polynomial, it can have at most 2. If it's a cubic, it's a third degree polynomial and it can have at most 3. Okay? So, linear has 1. Quadratic can have up to 2. And cubic can have up to 3. So on number 7, you want to write what I've highlighted. If it's a linear function, it means first degree. It will have exactly 1. If it's a quadratic and it's second degree, it can have at most 2. If it's a cubic and it's a third degree, it can have at most 3. So to sum it up, it just means the degree of the polynomial seems to indicate the maximum number of distinct real zeros a polynomial will have. So if I have a function, this is just an example, of x to the 10th power, I can have at most 10 real zeros. But I cannot have any more. Okay? All right, on number 8, it says, how can you determine the y-intercept of the graph of a polynomial function? So you know what a y-intercept is. It's where it crosses the y-axis. So, whoa. What you need to know for this is finding f of 0. So literally all that means, this is for number 8. Plug in 0 for x. To get y-intercept. So if you plug in your 0 for your x, then it will give you your y-intercept. All right, number 9 says, consider the graph of the quadratic function negative 2x squared plus or minus 3x plus 6. No, it's not this graph right here. So don't look at that graph. So you have to plug in a 0. So I'm saying, or not f, g of 0 equals negative 2 times 0 squared minus 3 times 0 plus 6. Well, we know that anything times 0 is 0. So this is 0, this is 0, and then we're just left with 6. So our y-intercept is 6. And if you write a coordinate point, that would be 0, comma 6, because I plugged in 0 for my x value and I got out 6 for my y value. All right, last one is number 10, and it's a drawing one. So, we're sketching a cubic graph. It says sketch the graph of a cubic function with zeros. Remember that zeros are x-intercepts of negative 2, 1, and 3. So first, I want you to go ahead on your paper and on here and do negative 2, positive 1, and positive 3. Okay? Now, it says it is concave down. And yesterday we learned that concave down means that the graph is pointing down. Then it says it goes concave up. And we know that concave up means that the graph goes up. So if you look, you see 2 important things here and here. So if it starts negative infinity and it's a concave down, you know that it's got to start from the bottom. It stops at 2/3 when my x is 2/3. So I'm going to go ahead and I'm going to make me a little mark at 2/3 approximately. Maybe not that far over. About here. So I know where to guide my graph. So you have to pass through the points, like the dots, your zeros. Here's our concave down. Then it starts going up, and we pass through our positive 3. And here's our funky graph. And if we hit check, it kind of looks the same. So, the yellow says, what does the graph indicate about the max and min values? And what do you notice about the y-intercept of the graph? So, on the back of your paper, on B, you've got a max point between -2 and 1. So on B, you can say max is between x equals -2 and x equals 1. Then you have a minimum point from 1 to 3. And then my y-intercept is 6. So if you look at your graph, let me erase all this. And I'll show you the, let me take my graph off. All right, there's a better look. So here's our max point. Here's our min point. Here's our y-intercept. These are our x-intercepts, our roots, and our real zeros. So don't forget, there's no practice questions that go with this lesson. But when you come to class on Thursday, I will be checking this lesson in your workbook to make sure you have completed it. So let me know if you got questions.